Hi everyone, welcome to lesson 22 of the Advanced Higher Stats course. In this lesson, we will be looking at the Wilcoxon sign rank test. By the end of this lesson, you should be able to do a one-tailed and two-tailed test for two samples and one sample, and you should be able to normally approximate. The types of tests you can have a one-sample test and a two-sample test, and these are the tests you can possibly be doing. In this Wilcoxon test, you are working with the median, which is this letter here. It's called eta. As a true median. For our assumptions, both the population distributions, or if it's a one sample, the one population distribution is symmetrical. You can normally approximate if the sample size is greater than 20. And to reject our hypothesis, our calculated statistical value has to be less than or equal to the critical value. So normally we're used to, let's say, getting greater than z greater than 1.64 to reject H0. But in this test, we want to get a statistical value less than our critical value to reject it. As always, we start with the one-tailed test. A random sample of 8 sixth-year pupils was taken. Each of the pupils threw 3 darts at a dartboard with the objective of obtaining as high a total score as possible. They then had a few days to practice, and the experiment was repeated to see if their scores had improved. We have the pupils A, B, C, D, E, F, G, H, and then we have the scores before, after. Test the claim that the practice improves the performance of sixth-year pupils. So what I would do here, I would say that our H no is the median difference is 0, and H1 is that the mean difference is greater than 0. Next, I would find the differences in these values. I'll just do it right underneath the table. So this got reduced by 1, so it's -1. This got increased by 5. This got reduced by 8. This increased by 18. This was 20. This was also 20. This was reduced by 9. This was increased by 5. Now I would rank them. I'll do that here. So the lowest number is 1. Then we have 2 positive 5s. And I'll cancel these whilst doing this. Next is a -8 and -9. I'll cancel them out. Then it's 18, 20, 20. 18, 20, 20. So that's our difference. And now I rank them. The first is the lowest number, so it gets a rank of 1. Since we have 2 5s, we add the next two numbers, so 2 and 3, that makes 5. Divided by 2 is 2.5. Each of them get 2.5. Then this gets 4, this gets 5, this gets 6. And same thing here, we add 7 and 8 because these 20s are tying, which gives us 15. Divided by 2 is 7.5. So these guys get 7.5, these numbers. Next, we calculate W positive and W negative, which I will do here. W positive is all the ranks of the positive numbers added together, and that gives us 26. And W negative is all the negative numbers ranks added up, which gives us 10. And what we're going to look at in particular is the lowest W value, which is 10. Next, we need to get a critical value. So it's a one-tailed test, and we've not been given a significance, so we automatically go for a 5% significance. Then we look at this table. It works with sample size. So we were given 8 6-year pupils. So sample size is 8. You have 5% significance. So our critical value is 5. So WC is 5. Since 10 is greater than WC, therefore, not enough evidence at 5% significance to reject H0 and suggest Practice improves the performance of sixth-year pupils. Now we'll do a two-tailed test. I recommend pausing the video to read this question. First thing we do here is we find the differences. I can write it, I can show it much easier now. And we'll start off with 3.1, 6.3, negative 5.7, negative 2.2, 12.3, 5.3, negative 1.2, to 0.1, 1, 12, 7.2, and 23.4. Next, I'm going to order these. And we'll start off with our 0.1, then 1, negative 1.2, 2, negative 2.2, 3.1, 5.3, negative 5.7, 6.3, 7.2, 12, 12.3, and 23.4. Now we can rank all of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Luckily, there's no duplicates, so we don't have to go through that slightly complicated or the extra step. Now we can find W positive, W negative. W positive is 75, W negative is 16. Now, we were not given a significance, so we just go for the 5% significance. This is two-tailed, and the sample size, it says here's 13. We go to 13, we go two-tailed, and it's 17. The critical value is 17. I'll write my conclusion here. Since 16 is smaller or equal to the critical value, therefore enough evidence at 5% significance to reject H naught and suggest the median change in aluminium concentration from August to November differs significantly from 0. Comment on any concern that you may have about the valid application of this test. We're assuming that the distributions of the populations are symmetrical here. Let's move back to a one-tailed test, but this time we have one sample instead of two. There's a small change I want to look at here. Pause the video to read the question, and I'll just jump straight into it. A necessary assumption: perform a Wilcoxon sign rank test to determine whether the colony's health is at risk. So the assumption is that the mite count distribution is symmetrical. Let's write our hypothesis as well now. So H naught is that the mean, or the median, eta, is 7, and H1 is that eta is greater than 7. Now we have to write these values in a column, get the difference by take away the median, order them, rank them, and let's do that now. That is now done here. I have the values here, the difference here, and I've ordered them, and then I've ranked them. The one thing I want you guys to look at is that whenever you have a observed value that is the median or the assumed median, you just cross it out, and it should never, it isn't included in your statistical analysis. So that means what your sample size originally was, you minus it by 1. So before it was 14, now it's 13. Then you use that to get the critical value. So let's say the critical value first. N is 13 now. We want this to be a 5%. So the critical value is 21. Let's find W negative and W positive, which is 14 and 77. And then let's write our hypothesis down here. Since 14 is less than a critical value, therefore enough evidence at 5% significance reject H naught and suggest there is a risk to colony health. So that's all I wanted to do for this one sample one. The main point is that if you have a observation that is equaling to the median and the difference is 0, you just cut that out of your data. Last but not least, we are looking at the normal approximation. We did this question for the one-tailed test, and now we're doing part B. Using a normal approximation, calculate an appropriate p-value for this test. Comment on the use of the normal approximation for the experiment. We could just start with a comment and get out of the way, and that is n is less than or equal to 20, so we shouldn't normally approximate. So we shouldn't normally approximate. Now we can now we do normally approximate because we've been asked. You'll find on page 15 of your data booklet, it'll tell you how to get the expected variance values. And by putting them in a calculator, you will get 18 and 51. Next, it's asking you for a p-value. So if I were to draw this distribution here, put 18 here, put 10 here, draw a dotted line here, it's asking for this value here. So how we go around getting that is by getting a z value. So z is equal to 10 minus 18, but we are making a slight mistake here. We need to do a continuity correction. So 10 turns into 9.5 and 10.5. This is more talked about in our normal approximation video. So instead of 10 minus 18, it's 9.5 minus 18 over the variance, which is the standard deviation, which is root 51, and that gives us negative 1.05. Now, probability of finding z being less than or equal to negative 1.05 is the same as 1 minus the probability of z being less than or equal to 1.05, which is 1 minus 0.8531, which gives us 0.1469, which is our p-value. Now you should be able to do a one-tailed and two-tailed Wilcoxon sign rank test for both two samples and one sample, and you should be able to normally approximate with Wilcoxon data.